Hello everyone, welcome to this session. Today we will learn of the most powerful method to split the point in a plane. So let's say we have this 4 point arranged like this and we want to split them. It seems again that a line won't do this job. So we need to think what could cut the data. It could be a curve that could split the data. And another could be the plane considering the point in a 3-dimensional space. So what do you think is the best solution? Well, these two ways are same, and this method is known as the kernel trick, and it is well used in the support vector machine. So let's study this in a more detail. First start with a curve. We will put the coordinate of the point and we need to separate the green and the red points. So if the point coordinates are x and y, we need to an equation in terms of x and y by which we can derive the equation of the curve that separates the point. So which of this following equation do you think will separate the points? Whether it will be sum of the coordinates or product of the coordinate or square of the first coordinate. Pause for a moment and think about it. So let's draw the table for each coordinate and equation and calculate its value based on the equation. So here is the table. So here we see that the first equation output is same for the red and the green point. So this would not work. Third equation output is 0 and 9 for the red points and 1 and 4 for the green point. This will also not work. Now, second equation output is 0 for the red point and 2 for the green point. This would work better. So here we see that the coordinate of the point xy and the product of the coordinate xy. So for the red point product xy is equal to 0 and for the green point product xy equal to 2. And what separates the 0 and 2? Well, it is 1. So the equation will be xy equal to 1. And it is same as y equal to 1 by x. And the graph for the curve y equal to 1 by x is in hyperbola. This is the curve which we wanted. Now let's look in the 3 dimension. So we recall that the equation xy will separate the point. So we have the point whose coordinate are x and y. Now consider another axis, z axis for height. So let's say we add xy to our coordinate. Now coordinate of the 2 dimension changes to the 3 dimension. That is x, y and xy. So here we see that the green point is at the height of 2 and red point remain underneath. And what will separate this? Well, plane would separate this point. This is a way to visualize the kernel trick in 3 dimension. So now move to the another model. Let's say we have to open the pizza parlor in a city. And we realize that the people who eat pizza most reside in these areas. So we decided to open the pizza parlor. And we need to know where could be the best place to open. It seems that houses are nicely separated into 3 groups: red, blue and green. It would be better to place one pizza parlor in each group, but computer don't know about that, how to do. So we need an algorithm to do that. So here is the algorithm. Let's choose 3 random location for the pizza parlor, which is marked as black star. So people who live close to the pizza parlor will prefer to go to those pizza parlor. Here, the one who are close to the red pizza parlor will go to the red pizza parlor. So which is encircled by this red circle. Same for the blue star and the green star. It would be better to move now. If we see that a blue pizza parlor is far away from the blue houses, and same for the green and the red. So it would be better to move the pizza parlor to the center of the each cluster. So the optimized location of the pizza parlor can be suggested if we utilize K-means clustering algorithm. And in this algorithm, we need to specify the number of clusters to end up with as per a given data. But what if we don't know how many clusters to end up? In that case, we use a hierarchical clustering. Suppose we have to decide the number of clusters based on this data, which is in the form of the black dots. First, we will pair the houses which is close by, like these two houses. Same way for the others also. We have paired the houses which are close by. Now we see that this house is also close to this house. But how we will pair them? Because it is already paired, so we can group all these three houses to form a cluster like this. Same way for the others. These two houses are also nearby, so we will make a cluster. Same way, these two houses are close by, so we will make a cluster. Same for these two houses. Now we see that these two houses is also, so it could also be paired up, but these two houses are far apart. We will stop them. Whenever two closest houses are this distance apart, we will stop the algorithm that will control how far we want the cluster to be apart. And this algorithm is known as a hierarchical algorithm. So here we saw that this algorithm is useful when we don't know the number of cluster, but we have an idea about how far we want them to be. So we have learned the main algorithm used in the machine learning. We have learned how to predict a house pricing using the linear regression, to detect spam emails using the naive Bayes, to recommend the app using the decision tree. We have learned the model for admission officer using the logistic regression and support vector machine. We have learned how to improve using the neural network and kernel method. And finally, we have learned how to locate the pizza parlor around the city using the clustering algorithm. So many questions might be arising, like are there more algorithms? And answer is yes. How do we know which algorithm is better? We will learn how to compare them based on the given data set, like running time, accuracy, and many other factors. Can we combine all this algorithm? The answer is absolutely. So in further class, you will learn more about this algorithm. So that's all for this video. Hope you enjoyed learning this algorithm. See you in the next class. Thanks for watching the video.